Okay, so it turns out the program I'm using to record my screen here, I got the free version, so it only goes up to 15 minutes, and it looks like I'm going to go a little bit over that. Okay, so where were we? Integral calculus, the second branch of calculus in the last 1/4 of the course, is called integral calculus, and what we're going to study, very different from differential calculus. Here, we find the net change of some quantity, and that's known as the definite integral. Geometrically, this is represented by the area between f of x and the x-axis starting at a and ending at b. And you can see that here if we've got some function, we say, okay, it's the area between this function and the x-axis starting at a and ending at b. So we kind of section this off. We're going to be able to find these areas exactly with the methods that we're going to develop. Now this seems like, how could this be connected to the idea of the instantaneous rate of change in the derivative, right? Back on the previous slide, if I can, there we go. Right here in the first 3/4 of the course, we're studying the tangent line, and really the slope of the tangent line is what we're interested in. The slope of the tangent line tells us how fast the function is changing at that moment. How is that at all connected to these curved areas, right? And that nobody saw that connection for many years. And then the huge breakthrough happened. It was in the late 1600s, maybe mid 1600s. They realized actually these two ideas of differential calculus and integral calculus are opposites of one another. So the methods we're going to use to perform differential calculus, it turns out if we were to do the reverse, then we would be doing integral calculus and finding those kind of curved areas. So obviously we need to develop a lot before we can explain how that works and all the concepts, but that's what's gonna unfold with the class. So we spend a long time talking about derivatives. Then we start to get into integrals, and near the very end of the course, we will have a section called the fundamental theorem of calculus. So you don't want to miss that one. That's a big one. Okay, just wrapping up now, what are the goals of this course? And I could think of 3 goals when I thought about it. We're going to develop the concept of the derivative and the concept of the integral. Okay. We're going to perform derivatives and integrals on all basic functions. That will be plenty enough in our course just to focus on basic functions. And then number 3, we're going to use derivatives and integrals in a variety of applications. Obviously, we call this Applied Calculus 1. And so we're going to see a lot of applications, some to physics, a lot of stuff to economics, and various things along the way. Okay. Then I found this photo. I thought it was fitting. It says, "A goal without a plan is just a wish." Kind of on a coffee napkin there. Well, we have these goals, so we need a plan. Well, luckily we've got a plan, right? We've got a calendar, how we're going to follow, and homework and all that stuff. So best of luck to you guys. Check out the first section, and that's all for our introduction.